Stu is working on the Morris, which is looking absolutely awesome because we've got the final wheels on it. And big giveaway here is that the final colour is going to be the colour that the wheel centres are. I don't know if we mentioned this before actually. It's been a controversial decision. The owner said from the very start that he wanted it to be purple. I mean, he talked about the Ford purple, I think it's called Velvet, purple Velvet. And I wasn't mad keen on that. And we talked about a few other ideas, definitely all kept coming back to purple. So we've been doing loads and loads of purple trial colour spray outs. And eventually we've settled on a custom mix, which is based on the Rolls-Royce, I'm going to forget the name of it now, I think it's something like Twilight purple, which is also very similar to the BMW colour of the same name, I guess because the two companies are linked. So we've done our own mix with some additional pearl additives in there, which give it a slightly bluer tinge. I was concerned it was slightly too pink in certain lights. It's made it more blue and given it a much bigger flip from the highlights to the shadows, so you get a bigger colour change basically depending on how the light hits it, which is going to work really well on the sort of curvy shapes of that. So I think it's going to look absolutely stunning. So we needed to make that colour choice so we could paint the wheel centres, so we could build up the split rims because they need to be painted before they're built. And so we could get them on the car to do the final wheel clearance checks. We've had a set of mock-up wheels on it the whole time, but I wanted the actual wheels with the actual tyres on to be 100% sure. And that's what Stu's been on with. He's basically been going through the full wheel travel range with it. He's rolled the lips right in now, just massaged the lips slightly outwards just to give us a tiny bit more and made sure they're dead symmetrical side to side. And he's been working on a lot of the lead work. It's basically all the final finessing of panel gaps and lead filling. So there was an original factory join where the headlight on the inside edge meets the wing, which the owner said he wanted to get rid of, so that's been leaded in and smoothed. Lead work over all the front modifications around the headlights, and leading back in any of the factory leaded areas that came out when it was pyroed and blasted earlier when we started the project. He's been guide coating and body filing all of the wings to make sure they're going to need a minimal amount of filler on them. Yeah, pretty much there really. He's been doing a little bit of work on the doors. We've got the frames in the doors and we want to get some door seals in there and just be absolutely happy with the way the doors open and shut and the seal gaps all the way around at this stage. So he's just been doing a little bit of work. We noticed on the far side that we'd welded up a crack in the B pillar, and going back over the dimensions again, we think that pillar had cracked previously because it had come out slightly. So with the door aligned with the wing, it was actually probably 3 or 4 mil out of line, top to bottom, where it meets the quarter. And our conclusion was that was because that crack was where the quarter had moved out at some point in the past. So we've split that again, pulled the quarter in probably 3 mil, and then welded the crack back up again, which has just tweaked the top of that quarter in so we can get the door alignment perfect all the way down to the wing. So yeah, it's just finishing the door alignments, and that's it. We're going to pull that apart and start prepping it for paint.
Since I'm stood right in front of it, I'm going to give Jamie a gamble as to which cars he's going to talk about. We're going to quickly talk about the Morris because this is on the brink of being stripped down. I believe that Stu will be starting to strip this back down tomorrow. I think he's got literally 3 little bits still to tweak. I'm just looking over at various things, but yeah, I think he's got about 3 little bits still to tweak. And a couple of little minor things to do with it. I think he wants to make some guides, some little nylon guides for the bonnet when the bonnet closes. I think he's got 1 little bit of a panel gap on the side of the boot lid that he's not quite happy with. And I think there's 1 little tweak on a wing, but he's pretty much finished. You know, it was kind of finished a couple of days ago, and then there was a couple of bits that have cropped up and a couple of things we've realised we need to just tweak slightly more. But then that tomorrow, all being well, if failing that Monday, but I think tomorrow, should be going on to the lift to be stripped down, to have all the underpinnings removed from it, ready so that they can then in turn be all stripped down, ready for all the sub-operations pardon me, that need to occur on all those sub-assemblies. So for example, picking the easy one, front and rear axle assemblies, both Mazda MX-5. They'll be removed from the car, completely stripped down, all the nuts and bolts dismantled. We'll assess all the fasteners on those to make sure, to decide whether they can be reused or not. If they can be reused, we will put them in for our process of bead blasting. Well, then they'll go for zinc plating, or zinc nickel plating we'll be using on those. So they'll go through that process. If they can't be reused, then we'll source replacements. The existing suspension bushes will all be removed. The wishbones will be checked over for any damage. If there's no damage on them, they'll be put through the process where we would get them shot blasted, zinc metal sprayed, and then powder coated. Same with the actual subframes themselves. The front subframe needs a minor tweak where the engine sump sits, the rear-wheel drive ZTEC sump. There's a Ford ZTEC engine in this, remember. There's a small tweak that needs doing on that front subframe to allow clearance for the sump. A little bit of a cutout we've got to do on that. It's roughly cut out at the moment from when it was on the jig. You couldn't really get in to do that on the jig. So now, once we drop that subframe out, we can then tidy up that cutout and weld that up and make that, neaten that before that goes off for shot blast, zinc metal spray and powder coat. Same with all the rear end parts, and then all the other parts will be divided up for all their various process routes. This is all made a lot easier now by the central stores that we have on the mezzanine next door, where we can actually keep all the parts slightly more easily together. So yeah, that's where we're at with Morris.
The Morris, which is just lurking over there, big change since last week. Last week was basically the culmination of the dry build on it. So I think it was sat here, completely built up mechanically. Stu was happy with everything metalwork wise. So over the course of the last week, he's been stripping that back down. The shell's just completely bare now on the ramp over there. All the running gear's out. The front and rear subframes are on a pallet over there, which is shortly going to be taken next door. So we can start disassembling that. We'll get the main subframe components blasted and start ordering up all the parts to rebuild it. So things like the bushes and ball joints and all the wearing replaceable parts, we'll get all those ordered up so we can get the subframes rebuilt in the background while the guys are working on prepping and painting the body shell. Morris is the remaining thing, and there's been sort of 2 avenues of progress on that. George has been on with a couple of different jobs on that. So he was designing the rear number plate light housing, which is going to be a machined and then chromed part, which not only holds the number plate light, but it's also a mount for the reverse camera. So the camera kind of will recess through into the boot lid, so it doesn't protrude out miles, but it'll have a little round aperture in that number plate mount that the camera sees through. And then he's also been on with a continuation of the door latch mechanisms. So he previously redesigned the entire door handle and all of the mounting for it. And then we've been working on refining the mechanism that the central locking motor and the interior door handle actuate on. So he's got a little bit he can tell you about on that now.
Hello and welcome to all the Morris work I've been doing over the past, 2 weeks. So I'm going to start with the central locking and latch. So this is the motor we're going to be using, which works with like buzzers and potentially keyless entry, but I don't know if we're doing that. But the issue with it is the size of it and the lack of size in the Morris door. So the only place I can actually put this is right in the bottom corner of the door facing up. The problem is the latch we're using is an in and out motion. So I've had to create this little jig piece, which, ignore the amount of play in it at the moment, because these are all going to be shoulder bolted, but this is just a mock-up at the moment. So yeah, this little jig piece here then converts it from an in and out motion to a up and down motion, which is one of the little engineering-y bits which I've had to do. Next, I think Jamie's got some nice B-roll footage of all the other things I've been doing inside the door. So we've been converting it to using more of a conventional style rod for the actual door handles, in conversion to what we was going to be using, which was tiny little rose joints on rods, which is a bit more complicated. So now we've converted it to use a conventional, almost lock style with conventional style clips. So that's all been kind of condensed down and shoehorned into the gap that we have. And then next on the list for it will be test fitting everything with all the trim pieces. All the door handles are all done, and then getting the interior door handles done, which we're going to be converting the look of to make them a lot more similar to the exterior door handles. And that's it for this so far. So Yeah.
So that's what George has been up to. And then the obvious other change, as you can probably see, is that it's been blasted and zinc metal sprayed and epoxy primed, which is the phase that we do between completion of metalwork and start of prep for paint. And Nat's got a little bit to tell you about on that.
We're about to do the zinc metal spray. We've just finished blasting the side of the Morris Minor. That's been blasted. We blasted key up all the fresh metal so that we've got a good surface for putting an epoxy primer on the top side of the car. But on the underside, we've covered this a number of times on previous videos, but we apply a zinc metal spray coating, basically a sprayed galvanizer to the underside of the car to prevent corrosion, a sacrificial coating to prevent corrosion, before we then epoxy prime and put a U-POL wrap to truck bed liner, urethane truck bed liner coating over that. So in order to do the zinc metal spray coating underneath, we use basically this setup we've got in front of us here. We've got a little cobbled up thing that I've made to pay out a zinc wire. This is 1/8 of an inch diameter, pure zinc, or as good as pure, 99 point something percent pure zinc metal wire. And then we have this Metco metal spraying gun, which is a high-speed metal spray gun. They do a couple of variants. They do ones for building up shafts and things with molybdenum and that sort of stuff, where you're feeding them with a very small amount of wire. And then they do ones like this, which are a high-speed metal spray gun, which is used largely for corrosion prevention, spraying things like zinc wire and aluminium wire. It's a common process, but not commonly used in the car industry. It's mainly used on bridge constructions, marine constructions, commonly used on boats, on fishing boats when they're rebuilt, that sort of stuff. It wasn't on many boats when they were originally built, but it's often used on rebuilds. Used on things that are used in really harsh environments generally. A lot of the cabinets you see on the side of motorways, things like that, that need to resist salt spray and all the horrible stuff you get sprayed off traffic on the side of motorways, have a similar coating, usually a zinc or aluminium metal spray coating. These days it's often done with an arc spray system rather than a flame spray. This is flame spray. So what we have, Metco gun, that's fed with propane from a bottle via a regulator, then a flow meter, which I can use to adjust the flow to my gun, to the mixing valve on there. Then we've also got oxygen from the bottle, regulator, flow meter to the gun. That's critical because the flows are quite important on this, so you have to regulate them more than you can do with just a regulator. And then lastly, compressed air, which is fed via a regulator on there to the gun. What happens is,
there's a flame very similar to a cutting torch in the end of there. It's just a bit like a different version of a cutting torch nozzle, only far more expensive because everything that flame spray related is very expensive. It has a multi-hole nozzle in there which is fed with the oxygen and propane, and basically has a ring of jets around which heat the zinc wire up. The zinc wire is fed through the middle. It's driven through by an compressed air driven turbine, which is inside here, and that adjusts for speed like that. And that alters, there's a pair of pinch rolls, a bit like on a MIG wire, the MIG wire feed rolls on a MIG welder. That feeds the zinc wire through the gun, through out of the middle, and it feeds it through the middle of the flame in there. That liquefies it, and then the compressed air is then sprayed out through this air cap, which is not unlike a spray gun air cap, only more crude and rudimentary. That atomizes the molten zinc and sprays it out at the end. So you're basically spraying molten zinc with the end of the gun. At a sensible distance, somewhere between yay and yay, that zinc then sticks really effectively to very freshly blasted metal. The key is the metal has to be freshly blasted, which is why we've literally just finished blasting this, and I'm now going to set to and flame spray it now while it's completely fresh. And then as soon as that's done, we're then going to take the car out and we're going to get the epoxy primer on it while it's still completely fresh on the top side. The underside we won't epoxy prime yet because we seam seal it while it's still just in the zinc. Well, that's the theory of the process. Basically, we take an 1/8 inch zinc metal wire, atomise it, spray it, and basically spray that onto the completely clean, bare, freshly blasted metal. That's blasted with a mixture of glass grit, which again, we mentioned before, we've shown before. You have to apologise for my overalls, they're a bit torn. Yeah, that's the crushed glass, which is recycled bottle glass that we blast the car with. And that gives a perfect finish to then be able to apply the zinc over it. So that's what I'm about to do. I'm about to don my PPE. A couple of people have asked in the past as well, why do I wear this, not have an air-fed system? I could agree, an air-fed would be lovely, and far nicer for me than this. However, I definitely won't breathe any zinc in with this. And the problem is, as you can see, I'm already dragging 3 umbilical pipes plus a zinc wire. Try to drag another 4th umbilical pipe. The manoeuvrability becomes so bad that I'd rather just, because for the relatively short amount of time I've got to wear it, I'd rather wear this, do the job that way, than try and drag yet another pipe around with me in there just to get tangled up in, because it's already a pretty tangly operation with what I've already got. So that's why I use that and not an air-fed for this job. It was a deliberate choice. So yeah, all good. I'm sure you'll see a bit of footage of this happening shortly. So there we go.
So yeah, that's where we're at with the Morris. But that's that, and with that out of there, the Morris is in. So flat out on the initial filler work and prep work on the Morris. The guys have also done the seam sealing on that first. So yeah, I mean, we're all very excited to see that take shape. It was cool seeing it all with the changes in the metalwork, and with it sat here kind of as a bare metal shell. It looks mean and purposeful, but at the same time, you sort of can't wait to see it all come together with paint on it. So yeah, really excited to see that transform over the next few weeks. A little wander over here. The Morris. The Morris is basically in that point of body prep where it's just putting material on and sanding it off again. So that's exactly what Steve and Gaz are doing at the moment. Lots and lots of going around the car, filler skimming, block sanding, getting all the gaps absolutely perfected. They're almost at the point now where they'll get the full coating of sprayable polyester over the whole car. You get to this point they're at now, and it starts to get, it's extremely close to the shape you want it to be. It starts to get quite difficult to see the wood for the trees because everything is such a patchwork quilt of different colours. And also you have problems where, because the filler sands more quickly than the surrounding metal, the transitions create a little undulation. So pretty much the next step now is going to be get a polyester coat over the whole lot so we can really review the shape again, you know, without being distracted by the varying colours on there. And then we'll do another block sanding session of that, but it's looking good in terms of all the shapes, the gaps, everything's looking great on it. So that is very exciting to see that coming forward. And then George has been working on some more machine parts for that. So he's been drawing up the interior door handles. He's already done the exterior door handles as a new design part. All of the assembly that holds that, all of the actuation rods that go to the motors and locks for that, that's all done. And then we wanted to tie in that slightly revised version of everything on the inside as well. So although the handle still works in the original rotary fashion and vaguely resembles the original, it's just kind of cleaned up, slightly more angular. It's got a little taper design on it, so it starts off slightly fatter and then slims down. It's just a slightly sharper take, shall we say, on the original. So yeah, that's going to be added to the ever-growing list of parts that are going to need to be machined for that. And on that note, I think that is it for this week. So I'm looking forward to seeing what the next week holds in terms of progress, and we'll catch you again next weekend. See you then. There's also some progress on the Morris. Might just have a little wander over here actually, or at least face this way, because you can see the engine sitting over there. As a very brisk recap, the Morris is running all Mazda MX-5 suspension and subframes. It's running a Ford Zetec 200 horsepower Omex built Ford Zetec engine and a Mazda MX-5 gearbox, although it's actually a later gearbox, so it's an NC gearbox and it's NB subframes and suspension. So on the bottom of that trolley is actually the new gearbox. We've got a used gearbox for all the mock-up, because obviously at that stage we're never 100% sure whether everything's going to work as we think it will. So just a cheap used gearbox for all of that mock-up stage, and now we know it's all going to work. We've just gone to Mazda and got a brand new gearbox. To be honest, the price difference between rebuilding the existing one, when you include all of the surface finishing processes, bead blasting the casing, plating all the parts, all of the replacement parts and the physical rebuild of the box, the price difference is negligible to buying a new one from Mazda, and at least then you know that it's built by Mazda rather than a gearbox refurbishment company. So that's that. They've been bolting some of the parts onto the engine, so the TTV flywheel and clutch are fitted, and then the adapter plate that adapts the Zetec to the MX-5 gearbox. There is one available from Retro Ford, but the starter motor position didn't really work out with the MX-5 subframe, because obviously it's not designed for that. And we wanted the starter motor to sit under the throttle bodies. So we have done our own adapter plate, which we've drawn up, and then we did a test fit in just a plasma cut stainless steel, mild steel plate. All went well. So Gary at Dynamic Precision has machined the final adapter plate in aluminium. I think we had the blank water jet actually. We had the blank for that water jet out first, and then Gary did the final machining on it, so he didn't have so much material to take out. But yeah, that's ready to go now. So it's kind of, you've got the whole engine and gearbox assembly there. And then in terms of the rest of the mechanicals, we're trying to get everything in progress at the moment. So the subframes, wishbones, essentially all the fabricated steel parts of the Mazda drivetrain have been away for media blasting, zinc metal spray, which gives it the corrosion protection, and powder coating. There's a huge batch of parts away for Xylan coating as well. Lots of that is fasteners, so nuts and bolts, etc., for all of the suspension, because it's just a much tougher finish than zinc plating. And what else have we got away on that? We've got a lot of parts coming. That's probably the other notable thing on that. So all of the wearing parts from the drivetrain, all things like bushes, ball joints, etc., they're all coming from Mazda. So essentially we're just building everything up in the background in terms of the suspension and mechanicals, so that when the guys have finished the paintwork, which you'll see in a minute, we can hopefully get it all bolted together and get it rolling fairly promptly.